close your eyes, and let's drift outward, beyond Earth, beyond our solar system, into the vast spiral of stars we call home, the magnificent island of light floating in the cosmic ocean, our Milky Way galaxy. Our story begins with a name that evokes something familiar and nourishing. The Milky Way gets its name from the Greek galaxias kyklos, meaning milky circle, which Romans translated as Via Lactea, the Milky Way or Milky Road. Ancient peoples looking up at the night sky saw this faint, milky band of light stretching across the darkness and wove it into their myths. The Greeks believed it was milk spilled from the breast of the goddess Hera. Norse mythology described it as the pathway souls took to reach Valhalla. Chinese astronomers called it the Silver River. These ancient names all captured the same quality, this luminous, cloudy path that seemed to flow across the heavens, mysterious and beautiful, a river of light in the dark. Let yourself relax as we consider what creates this milky appearance. When you look up on a dark, clear night away from city lights, that band of light stretching across the sky isn't a cloud or mist, it's the combined glow of billions of stars too distant and numerous for your eyes to separate into individual points. You're looking at our galaxy from the inside, seeing it edge on, peering through the disk in which our solar system sits. The Milky Way is a spiral galaxy, shaped like a vast cosmic whirlpool with graceful arms curving outward from a bright central bulge. From our position within this spiral, we see the greatest concentration of stars when we look toward the galactic center or along the plane of the disk, creating that characteristic milky band that wraps around the entire sky. Now breathe slowly and picture the sheer scale of our galaxy. The Milky Way is approximately 100,000 light-years in diameter, meaning light, traveling at 186,000 miles per second, takes 100,000 years to cross from one side to the other. To put this in perspective, the fastest spacecraft humans have ever built, Voyager 1, traveling at about 38,000 miles per hour, would take roughly 1.6 billion years to cross the galaxy. That's longer than complex multicellular life has existed on Earth. The Milky Way contains between 200 and 400 billion stars. The exact number is uncertain because we cannot see the entire galaxy clearly from our position within it. Each of these stars is a sun, many with their own planets, many possibly hosting worlds we'll never know exist, separated from us by distances so vast that their light takes millennia to reach our eyes. As you sink deeper into tranquility, consider our position within this immense structure. Our solar system resides about 26,000 light-years from the galactic center, roughly halfway out from the core to the edge, in a minor spiral arm called the Orion Spur or Orion Arm. We're in the galactic suburbs, far from the crowded, energetic center where stars pack more densely and where more dramatic events occur. This location has been fortunate for Earth, too close to the center, and we'd be bathed in more radiation, face more frequent supernova explosions nearby, and encounter more gravitational disturbances. Too far out, and the heavy elements necessary for rocky planets and life might be too scarce. Our spot in the Orion Spur appears to be a Goldilocks zone for the development of life, not too extreme, not too quiet, but just right. Here's something peaceful to contemplate. Our entire solar system, along with all the other stars in the Milky Way, is in constant motion. The Sun, carrying Earth and all the planets with it, orbits the galactic center at approximately 514,000 miles per hour, or about 143 miles per second. Even at this tremendous speed, It takes about 225 to 250 million years to complete one orbit around the galaxy. This period is sometimes called a galactic year or cosmic year. The last time our solar system was in this same position in the galaxy, dinosaurs didn't exist yet. They would emerge later, evolve, dominate the planet for 165 million years, and then go extinct, all during just one galactic orbit. Every star you see in the night sky is also orbiting the galactic center, each following its own path, all participating in a grand, slow dance that has been continuing for billions of years. Let your thoughts drift to the age of our galaxy. The Milky Way is approximately 13.6 billion years old, nearly as old as the universe itself, which formed about 13.8 billion years ago in the Big Bang. The galaxy didn't form all at once but assembled gradually, as smaller groups of stars merged and accumulated over hundreds of millions of years. The oldest stars in the Milky Way, found primarily in the galactic halo and in globular clusters that orbit outside the main disk, are among the oldest objects in the universe, containing mostly hydrogen and helium with very few heavy elements, because they formed before multiple generations of stars had lived and died, creating and dispersing the carbon, oxygen, iron, and other elements that make rocky planets and life possible. The Milky Way has witnessed nearly the entire history of the universe, a structure that existed when the cosmos was young and will likely persist for trillions of years into the future. Rest now in this knowledge, floating peacefully within our galactic home, one of billions of stars circling the center in a dance measured in hundreds of millions of years, part of a structure so vast that light takes 100,000 years to cross it, yet so familiar that humans have gazed upon it and named it for all of recorded history. Breathe slowly and let yourself drift deeper into the spiral, as we explore the structure and architecture of our galactic home. Let us journey now to the center of the Milky Way, a region hidden from our direct view by vast clouds of dust and gas. At the very heart of our galaxy, approximately 26,000 light-years away from us, lurks Sagittarius A*, pronounced A-star, a supermassive black hole containing about 4 million times the mass of our Sun, compressed into a region smaller than Mercury's orbit. Scientists discovered this monster not by seeing it directly. Black holes emit no light, but by watching stars orbit the galactic center at tremendous speeds, their movements revealing the presence of something massive yet invisible. Some of these stars complete orbits in as little as 16 years, racing around at speeds up to 5,000 miles per second, or about 3% the speed of light. Their swift motion betrays the presence of Sagittarius A*, sitting silent and dark at the heart of our galaxy, a gravitational anchor around which hundreds of billions of stars ultimately revolve. As you relax even deeper, consider the galactic bulge, the bright, roughly spherical region at the galaxy's center. This bulge contains predominantly older, reddish stars packed much more densely than in the outer regions where we live. In the galactic bulge, stars are separated by light weeks or light months rather than light years, still vast distances by human standards, but close by cosmic measures. If Earth orbited a star in the galactic bulge, the night sky would be spectacular, filled with thousands of stars brighter than Venus appears from Earth, so many that they would cast visible shadows at night and the Milky Way's band would be far more prominent. The bulge also harbors a bar-shaped structure of stars, making the Milky Way what astronomers call a barred spiral galaxy, a central bar with spiral arms extending from its ends rather than from a circular bulge. Let your thoughts drift to the spiral arms themselves, those graceful curves that give our galaxy its characteristic appearance. The Milky Way has two major spiral arms, the Perseus arm and the Scutum Centaurus arm, along with several smaller arms and spurs, including our home in the Orion Spur. These arms aren't rigid structures but are density waves, regions where stars, gas, and dust temporarily bunch up as they orbit the galaxy at slightly different speeds. You can think of spiral arms like traffic jams on a highway. Cars enter the jam from behind, slow down, bunch together, then accelerate away as they leave, but the jam itself remains in roughly the same place even as individual cars pass through. Similarly, stars pass through spiral arms during their orbits, spending time in these denser regions before emerging again. The spiral arms appear bright because they contain many young, hot, blue stars and glowing nebulae where active star formation occurs, making them stand out against the older, dimmer stars filling the spaces between arms. Now breathe gently and picture the galactic halo, a vast, roughly spherical region surrounding the disk and bulge of the Milky Way. The halo extends perhaps 100,000 light-years or more beyond the visible disk, making the true size of our galaxy much larger than the luminous spiral we typically picture. The halo contains old stars, globular clusters, dense balls of ancient stars containing hundreds of thousands to millions of stars each, and most mysteriously, dark matter. The halo stars are sparse compared to the disk. If you lived on a planet orbiting a halo star, the night sky would be profoundly dark, with far fewer visible stars, and the Milky Way's disk would appear as a distant, glowing plane. The halo also serves as a graveyard of sorts, containing the remnants of smaller galaxies that the Milky Way has consumed over its history, their stars now scattered throughout our galaxy's outer regions, testimony to the Milky Way's growth through cosmic cannibalism. As you sink into deeper tranquility, consider globular clusters, those ancient stellar cities that orbit in the halo. The Milky Way hosts about 150 to 200 known globular clusters, each containing between 100,000 and 1 million stars bound together by gravity into a sphere typically 100 to 200 light-years across. These clusters are among the oldest structures in the galaxy, some dating back more than 12 billion years. Because they formed when the universe contained fewer heavy elements, their stars are metal-poor. In astronomical terms, metals means any element heavier than helium. The cores of globular clusters are so densely packed that stars are separated by mere light days, close enough that gravitational interactions between stars occur, creating unusual stellar objects like blue stragglers, millisecond pulsars, and black holes that feed on companion stars. From a planet orbiting a star near a globular cluster's center, the night sky would never be dark, illuminated by thousands of nearby stars creating perpetual twilight. Here's something peaceful to contemplate. The Milky Way is not isolated but is part of a small group of galaxies called the Local Group. This cluster contains about 80 galaxies, though most are small dwarf galaxies. The two largest members are the Milky Way and the Andromeda Galaxy, M31, with the Triangulum Galaxy, M33, being the third largest. Andromeda is the Milky Way's big sister, containing perhaps 1 trillion stars compared to our 200 to 400 billion, and it lies about 2.5 million light-years away, close by cosmic standards. Andromeda is actually moving toward us at about 70 miles per second, and in approximately 4.5 billion years, the two galaxies will collide and merge, creating a new, larger elliptical galaxy that some astronomers have already nicknamed Milkomeda. This collision won't be violent. Stars are so far apart that stellar collisions will be rare, but the galaxy's structures will be completely disrupted, their spiral arms destroyed, their gas clouds shocked into massive bursts of star formation. Our distant descendants, if any remain, will witness a night sky transformed, with Andromeda growing larger over millions of years until the two galaxies embrace and become one. Rest peacefully now, knowing you reside in the outer reaches of a vast spiral, anchored by a supermassive black hole, surrounded by ancient globular clusters, part of a local family of galaxies slowly moving through space together, all engaged in a cosmic dance that will continue for billions of years. Let yourself drift even deeper into the galactic night, as we explore the matter and mystery that fill the space between stars. Drift with me now to the interstellar medium, the vast spaces between stars that aren't actually empty but filled with extremely diffuse gas and dust. About 10 to 15% of the Milky Way's visible mass exists in this interstellar material, primarily hydrogen and helium gas along with tiny dust grains made of carbon, silicon, and other elements. In most regions, this material is incredibly sparse, roughly 1 atom per cubic centimeter, far more empty than the best vacuum we can create on Earth. Yet across the immense distances between stars, this thin material accumulates, creating clouds massive enough to block starlight, creating the dark lanes and rifts visible in photographs of the Milky Way. These clouds are stellar nurseries, the birthplaces of new stars, where gravity slowly compresses gas over millions of years until it becomes dense and hot enough to ignite nuclear fusion, bringing new suns into existence. As you breathe slowly and peacefully, consider the massive molecular clouds, the largest and densest of these stellar nurseries. These clouds can be hundreds of light-years across and contain hundreds of thousands of times the mass of our sun in gas and dust. Inside these clouds, temperatures drop to just 10 to 20 degrees above absolute zero, colder than any place in our solar system. The cold and density allow molecules to form and survive, not just simple hydrogen molecules, but complex organic molecules including alcohols, sugars, and other carbon-based compounds, the building blocks that may seed planets with the ingredients for life. The densest parts of these clouds are so opaque that they block all visible light, appearing as dark silhouettes against the background stars, like the famous Horsehead Nebula or the dark lanes of the Great Rift that splits the visible Milky Way. Within these dark regions, hidden from view, new solar systems are forming right now, planets condensing from the swirling disks around infant stars. Let your thoughts drift to the spectacular emission nebulae, those glowing clouds of gas photographed by telescopes invisible as colorful patches in the Milky Way's spiral arms. The Orion Nebula, visible to the naked eye as a fuzzy patch in Orion's sword, is one of the closest massive star-forming regions at about 1,350 light-years away. These nebulae glow because hot, young stars embedded within them emit intense ultraviolet radiation that ionizes the surrounding hydrogen gas, causing it to fluoresce in the characteristic red-pink color seen in many space photographs. These regions of active star formation are violent and beautiful. Stellar winds from massive young stars carve cavities in the clouds, supernova explosions from short-lived massive stars compress nearby gas and trigger new waves of star formation, and ultraviolet radiation sculpts the clouds into fantastic shapes. The star-forming process is self-limiting. Eventually, the newly born stars disrupt and disperse the clouds that gave birth to them, ending that particular burst of star formation. Now breathe gently and picture the supernova remnants scattered throughout the Milky Way, the ghostly shells of gas expanding from stars that exploded centuries or millennia ago. When a massive star reaches the end of its life, it detonates in a supernova explosion, releasing more energy in seconds than our sun will emit in its entire 10 billion-year lifetime, and briefly outshining an entire galaxy. The explosion hurls the star's outer layers into space at speeds up to 10% the speed of light, creating expanding shells of gas enriched with heavy elements forged in the star's core, and during the explosion itself, carbon, oxygen, silicon, iron, and everything heavier. These supernova remnants are visible for thousands of years as they expand and gradually fade. The Crab Nebula, remnant of a supernova observed by Chinese astronomers in 1054 CE, still shines brightly in our telescopes. Supernova explosions enrich the interstellar medium with heavy elements, allowing subsequent generations of stars to form with more metals, making rocky planets like Earth possible. Every atom in your body heavier than hydrogen was created inside a star and scattered by a supernova. You are literally made from stellar debris. As you sink into deeper tranquility, consider the magnetic fields that thread through the Milky Way's interstellar medium. The galaxy has a large-scale magnetic field, roughly aligned with the spiral arms, created by the motion of charged particles in the gas and the galaxy's rotation, a cosmic dynamo effect similar to what generates Earth's magnetic field. This galactic magnetic field, though incredibly weak by everyday standards, about 1,000,000 times weaker than Earth's field, has profound effects across galactic scales. It shapes the paths of cosmic rays, high-energy particles traveling at nearly the speed of light, keeping them trapped within the galaxy for millions of years as they bounce along magnetic field lines. The magnetic field also influences star formation by providing support against gravitational collapse in molecular clouds, and it creates beautiful structures visible in radio telescopes, filaments and loops tracing the invisible magnetic architecture of our galaxy. Here's something peaceful to contemplate. The Milky Way contains a vast population of stellar remnants, the corpses of stars that died long ago. White dwarfs, the cooling embers of sun-like stars, number in the billions throughout the galaxy, dense objects about Earth's size but containing roughly the Sun's mass, slowly fading over trillions of years. Neutron stars, even denser remnants of massive stars, are only about 12 miles across yet contain 1.4 times the Sun's mass. A teaspoon of neutron star material would weigh about 6 billion tons on Earth. Some neutron stars spin hundreds of times per second, sending beams of radiation sweeping through space like cosmic lighthouses. We detect these as pulsars. And scattered throughout the galaxy are stellar mass black holes, typically 5 to 20 times the Sun's mass, the final evolutionary stage of the most massive stars. Estimates suggest the Milky Way contains perhaps 100 million stellar mass black holes, most of them solitary and invisible, drifting silently through the galaxy, detectable only if they have companion stars whose matter they consume or whose orbits they perturb. The galaxy is not just a collection of shining stars but also contains a vast population of dark, dense remnants, silent monuments to stars that once blazed brightly but now exist in forms almost beyond comprehension. Rest now in this rich galactic medium, where the space between stars teems with thin gas and dust, where new stars are born in cold, dark clouds, where old stars explode and enrich the cosmos with heavy elements, and where remnants of dead stars drift through darkness, all part of the Milky Way's ongoing cycle of stellar birth, life, death, and rebirth. Breathe softly and let yourself float through the final mysteries of our galactic home, where darkness reveals hidden wonders. Let us drift now to the mystery of dark matter, the invisible substance that makes up approximately 85% of the Milky Way's total mass. We cannot see dark matter, it doesn't emit, absorb, or reflect light, yet we know it exists because of its gravitational effects. The stars in the Milky Way's outer regions orbit faster than they should if only visible matter were present. Without additional unseen mass, these stars should fly off into intergalactic space, yet they remain bound to the galaxy. This invisible dark matter forms an enormous halo around the visible Milky Way, extending perhaps 300,000 light-years or more from the galactic center, dwarfing the luminous disk we see. What dark matter actually is remains one of astronomy's greatest mysteries. Hypothetical particles called WIMPs, axions, or perhaps something entirely unexpected. We live in a galaxy made mostly of something we cannot detect directly, our visible stars and gas floating like foam on an ocean of invisible matter. As you relax even deeper, consider the Fermi bubbles, enormous structures extending above and below the galactic plane, discovered only in 2010 through gamma-ray observations. These bubbles, each about 25,000 light-years tall, tower above and below the galactic center like twin plumes of high-energy radiation. Scientists believe they were created by a massive outburst from Sagittarius A*, perhaps from a period millions of years ago when the central black hole was actively consuming large amounts of matter, or possibly from an intense burst of star formation and supernovae in the galactic core. The bubbles are invisible to optical telescopes but glow in gamma rays and radio waves, evidence of violent events in the Milky Way's past. Our galaxy, which seems peaceful when viewed in visible light, reveals a more turbulent history when examined in other wavelengths, a reminder that we see only a fraction of what exists, that reality contains layers hidden from our limited senses. Let your thoughts drift to the satellite galaxies orbiting the Milky Way, small companion galaxies bound by our gravity. The two most prominent are the Large and Small Magellanic Clouds. visible as cloudy patches in the southern hemisphere sky, appearing to the naked eye like detached pieces of the Milky Way. The Large Magellanic Cloud contains about 10 billion stars and lies roughly 160,000 light-years away, close enough that we can study individual stars within it. The Small Magellanic Cloud is even smaller and more distant. These satellites orbit the Milky Way over hundreds of millions of years, and tidal forces from our gravity are gradually pulling them apart, stripping away their gas and stars. Eventually, they will be completely absorbed into the Milky Way, their stars scattered throughout our galaxy. Dozens of smaller dwarf galaxies also orbit the Milky Way, some containing only a few thousand stars. Remnants of larger galaxies are galaxies partially consumed, or perhaps formed from material left over from the Milky Way's assembly. Now breathe gently and picture the Milky Way's rotation curve, the relationship between distance from the galactic center and orbital speed. In our solar system, inner planets orbit faster than outer planets because most mass is concentrated in the Sun. Logic suggests the same should apply to galaxies. Stars far from the center should orbit slower than those near the center. But observations show something unexpected. Stars in the outer Milky Way orbit at roughly the same speed as stars closer in, contrary to what visible matter alone predicts. This flat rotation curve is one of the strongest pieces of evidence for dark matter's existence. The dark matter halo provides the additional gravity needed to keep outer stars moving fast, preventing them from lagging behind. Without dark matter, our understanding of the Milky Way's structure would be fundamentally wrong. What we see is just the luminous tip of a much larger, darker iceberg. As you sink into the deepest tranquility, consider that viewing the Milky Way from Earth is a privilege increasingly lost to light pollution. For most of human history, everyone could see the Milky Way's band stretching across the night sky. It was a constant presence, woven into countless myths and stories. Today, approximately 80% of humanity lives under light-polluted skies bright enough to obscure the Milky Way. 1/3 of humanity, including 60% of Europeans and 80% of North Americans, cannot see the Milky Way from their homes. Many children grow up never witnessing this celestial river, never experiencing the humbling sensation of seeing our galactic home with their own eyes. The Milky Way is still there, of course, shining as it always has, but our own lights have made it invisible. In truly dark sites, remote deserts, mountains, or southern hemisphere locations far from cities, the Milky Way appears so bright it casts faint shadows, so detailed you can see dark dust lanes and bright star clouds, so overwhelming it reminds you that Earth is not separate from space but embedded within it. Here's a final, peaceful thought: the Milky Way is our cosmic address, our home on the grandest scale. Just as you live in a house, in a neighborhood, in a city, in a country, on Earth, you also live in the Milky Way galaxy, in the local group, in the Virgo supercluster, in the observable universe. This galaxy has existed for 13.6 billion years, will persist for trillions more, and has been home to countless stars, many of which have lived their entire lives, died, and enriched the galaxy with heavy elements before our sun even formed. The atoms in your body were created in stars that lived and died in the Milky Way, were scattered through the interstellar medium, eventually condensed into our solar system, and became part of Earth and eventually you. You are not just in the Milky Way, you are of the Milky Way, made from its substance, born from its processes, a temporary pattern in the eternal flow of matter cycling through this galaxy. And when your brief moment ends, your atoms will return to the cosmic cycle, perhaps eventually becoming part of new stars, new planets, new forms of complexity yet to emerge. Sleep now, deeply and peacefully, cradled in the spiral arms of our galactic home, one consciousness among perhaps billions in the Milky Way, a brief spark of awareness in a galaxy that has birthed and will birth countless stars, a child of the cosmos resting beneath the same river of starlight that has guided humanity since the first humans looked up and wondered. Rest in the Milky Way, in the galaxy that is both your home and your origin, knowing you are part of something vast, ancient, beautiful, and ongoing. Good night, stargazer. Good night, galactic child. Sleep well in the knowledge that you orbit the center of this great spiral at 514,000 miles per hour, carried by the sun through the Orion Spur, one small part of a structure containing hundreds of billions of suns, all of us drifting together through space and time. Rest. Peace. Sleep. Tonight, allow your thoughts to drift upward, away from the noise of the day, and toward the soft glow of the night sky. Above you stretches a pale, misty band of light, quiet, ancient, and unhurried. This glowing river of stars is the Milky Way, the galaxy we call home. To the naked eye, it appears as a gentle haze, but in reality it is a vast spiral galaxy containing hundreds of billions of stars, each moving slowly through space in a long, patient dance. Our galaxy is shaped like a flattened disk with graceful spiral arms curling outward from a bright central region. At its heart lies a dense core, glowing softly through thick clouds of dust, marking the center of everything we see in the night sky. Though it feels timeless, the Milky Way is very old, about 13.6 billion years, forming not long after the universe itself began. Since then, it has grown quietly, star by star, orbit by orbit, carrying generations of suns within its gentle spin. Your home, Earth, is not near the center of the galaxy. Instead, our solar system rests in a calm neighborhood called the Orion Arm, drifting peacefully about 2/3 of the way from the center, far from the crowded core. Even here, motion is constant. Our entire solar system travels around the Milky Way center at roughly 500,000 miles per hour, yet the journey is so vast that one full orbit, known as a galactic year, takes about 230 million Earth years. As the galaxy turns, stars are born and fade. Clouds of gas slowly collapse under gravity, warming, glowing, and eventually igniting into new stars. Some of the light reaching your eyes tonight began its journey long before humans ever existed. And as you lie here, breathing slowly, imagine yourself gently carried along with this motion, drifting through a spiral of stars. Held in a galaxy that moves so slowly, it feels still. There is nowhere you need to go. You are already traveling. Quietly. With the Milky Way. As you continue drifting through the galaxy, the soft band of light above seems to grow deeper, richer, layered with quiet detail. The Milky Way stretches across an immense distance. From one edge of its disk to the other, it spans about 100,000 light years, meaning light itself would need 100,000 years to cross from side to side. Even at the fastest speeds we can imagine, the galaxy remains impossibly wide. Within this vast space, not all regions are equally bright. Thick clouds of cosmic dust thread between the stars, gently absorbing light and creating dark lanes that cut across the glowing band we see from Earth. These clouds are not empty, they are rich with material, waiting patiently to form new stars. In some of these regions, immense nurseries exist where stars are born. Cold clouds of hydrogen slowly collapse under gravity, warming until nuclear fusion begins. Over millions of years, a single cloud can give rise to thousands of stars, each one igniting softly into existence. Not all stars are alike. The Milky Way contains stars far larger than our Sun and others much smaller, glowing faintly for trillions of years. Many of the galaxy's stars are red dwarfs, quiet and long-lived, slowly burning their fuel in the dark. Between the stars lies interstellar space, filled with gas, dust, and faint magnetic fields. Though it seems empty, This material makes up a significant portion of the galaxy's mass and drifts slowly, shaping the future of new star systems. Near the center of the Milky Way, stars crowd together more tightly. Their motion becomes faster, gravity stronger, and orbits more complex. Hidden behind thick dust lies a powerful presence anchoring the galaxy's rotation. At the very heart of the Milky Way rests a supermassive black hole, known as Sagittarius A star. It contains the mass of millions of suns, yet it sits quietly, influencing the motion of stars without pulling them in. Even this black hole moves in balance, held steady by the galaxy around it. Nothing here rushes. Everything follows slow, ancient paths carved by gravity and time. As you imagine this quiet structure, spiral arms turning, stars being born and fading, dark clouds drifting without urgency, you feel how small movements can be calm, how great distances can feel peaceful. The Milky Way carries you gently onward, and there is no need to hurry. As the galaxy continues its slow turn, the spiral arms stretch outward like quiet currents in a vast cosmic sea. Here, stars are not scattered at random, but gathered gently into families. Some stars travel together in open clusters, loose groups formed from the same cloud of gas. These clusters drift through the spiral arms, their stars slowly spreading apart over hundreds of millions of years, still sharing a common origin. Other stars belong to globular clusters, ancient, tightly bound spheres containing hundreds of thousands of stars. These clusters orbit the Milky Way like quiet companions, many of them nearly as old as the galaxy itself. Surrounding the bright disk of the Milky Way is a faint, spherical region known as the galactic halo. This halo contains older stars and globular clusters, extending far beyond the visible spiral arms into the darkness. Within the halo, stars move along long, tilted paths rather than the flat orbits of the disk. Their motion hints at the Milky Way's early history, shaped by slow mergers and quiet encounters with smaller galaxies. The galaxy is not alone. Over billions of years, the Milky Way has grown by absorbing smaller galaxies that wandered too close. These ancient mergers left behind faint streams of stars, still drifting through the halo like gentle echoes of the past. Some of the oldest stars in the Milky Way contain very few heavy elements. They formed before many generations of stars lived and died, preserving a record of a time when the universe was simpler and quieter. Even now, the Milky Way continues to evolve. New stars form, old ones fade, and orbits shift gradually. Change happens slowly here, measured in millions of years rather than moments. As you rest with these thoughts, imagine the galaxy not as a place of noise or motion, but as a calm system of long, patient cycles. Stars gather, drift apart, and gather again. The Milky Way turns, and carries you with it, gently, through the night. Beyond the glow of the Milky Way's disk, smaller companions move quietly through the darkness. These are satellite galaxies, bound by gravity, traveling alongside our own. The Milky Way has dozens of known satellite galaxies, including the large and small Magellanic Clouds. These smaller galaxies drift slowly, their stars tracing long, graceful paths around the larger spiral they accompany. Over time, some of these companions are drawn closer. Gravity stretches them, pulling stars away in faint streams that wrap gently around the Milky Way, adding to its growing halo. Holding all of this together is something unseen. Most of the Milky Way's mass is thought to be dark matter, an invisible substance that does not emit light, yet provides the gravitational structure that allows the galaxy to rotate without flying apart. Because of dark matter, stars far from the center of the galaxy move faster than visible matter alone can explain. This quiet influence shapes the Milky Way on the largest scales, guiding motion without ever being seen. The Milky Way is not standing still. It is moving through space, drifting as part of a larger collection of galaxies called the Local Group, which contains dozens of galaxies bound together by gravity. Within this group, the Milky Way and the Andromeda Galaxy are slowly approaching one another. Their meeting is not sudden or violent, but a long, gradual dance that will unfold over billions of years. When they finally meet, their stars will pass by one another peacefully, reshaping both galaxies into something new, while individual star systems remain largely untouched. As you imagine this distant future, galaxies drifting closer, stars moving along patient paths, you can feel how slow the universe truly is. Nothing here rushes. Everything unfolds in its own time. And as the Milky Way glides onward, so do you. Carried gently toward rest. As the galaxy turns, clouds of color begin to appear, soft reds, deep blues, and faint purples glowing quietly against the dark. These are nebulae, vast regions of gas and dust scattered throughout the Milky Way. Some nebulae are places of beginning. Within them, gravity gently gathers material until new stars are born. These stellar nurseries glow softly as young stars warm the surrounding gas, lighting the clouds from within. Other nebulae mark endings rather than beginnings. When massive stars reach the end of their lives, they shed their outer layers into space, creating delicate shells of glowing gas that slowly expand and fade over time. Every element heavier than hydrogen, carbon, oxygen, iron, was forged inside stars like these. The Milky Way is filled with recycled stardust, and even the atoms in your body once belonged to ancient stars that lived and died long ago. Some stars end their lives quietly, cooling into dense white dwarfs that glow faintly for billions of years. Others collapse more dramatically, forming neutron stars, objects so dense that a single teaspoon of their material would weigh billions of tons. A small number of these neutron stars spin rapidly, sending out precise beams of radio waves. From Earth, they appear as pulsars, ticking steadily like cosmic clocks, marking time deep within the galaxy. Throughout the Milky Way, supernova explosions have occurred over millions of years. These powerful events help shape the galaxy, triggering new waves of star formation while gently stirring interstellar clouds. Even now, somewhere in the Milky Way, a star is being born. And somewhere else, another is quietly fading. As you rest with this cycle of beginning and ending, creation and release, you may notice how natural it feels. Nothing here is rushed. Nothing is lost. The galaxy breathes slowly and carries you with it toward deeper rest. The Milky Way moves as a whole, turning slowly, patiently, like a vast cosmic wheel. This rotation is not rigid or uniform. Different parts of the galaxy move at different speeds. Stars closer to the center complete their orbits more quickly, while stars farther out drift along more slowly. This gentle variation creates the graceful spiral pattern that defines the galaxy's shape. Spiral arms are not solid structures, but regions where stars and gas pass through, like slow-moving waves. As material enters these arms, gas compresses, and new stars are often born before drifting onward. Our Sun is one of these travelers, orbiting the galactic center at a steady pace. It has completed about 20 orbits since it first formed, quietly circling within the Orion arm. The Milky Way's disk is surprisingly thin compared to its width, only about 1,000 light-years thick in many places. From above or below, it would appear as a delicate, glowing line suspended in space. Above and below this disk, faint stars and gas drift into the halo, tracing long arcs shaped by gravity and time. These regions are calm, distant, and sparsely populated. The galaxy also emits light beyond what our eyes can see. Radio waves, infrared glow, X-rays, and gamma rays reveal hidden processes, star formation, magnetic fields, and energetic events unfolding silently. Much of what we know about the Milky Way comes from listening rather than looking, detecting subtle signals that travel through space long after their sources have faded. As these quiet motions continue, rotation within rotation, wave after wave, the galaxy remains stable, balanced, and unhurried. Let your breathing match this rhythm. Slow, steady, unforced. The Milky Way turns, and you drift gently along with it, toward rest. From Earth, the Milky Way appears as a soft ribbon of light stretching across the night sky. For thousands of years, humans have looked up and wondered at this glowing path. Ancient cultures saw stories in the stars, long before they understood that the Milky Way is our view from inside the galaxy itself, looking outward through its dense, star-filled disk. Because Earth lies within the Milky Way, we cannot see it from the outside. Our perspective is always internal, surrounded by stars in every direction, giving the galaxy its misty appearance in the sky. On very clear nights, far from city lights, the Milky Way becomes brighter and more detailed. Dark patches appear where dust blocks starlight, creating contrast within the glowing band. The brightness of the Milky Way varies with the seasons. At certain times of year, Earth's night side faces toward the galactic center, revealing a denser, more luminous portion of the galaxy. Even with modern technology, mapping the Milky Way is challenging. Dust obscures visible light, so astronomers rely on infrared and radio observations to gently peer through the clouds. Space-based telescopes have helped create detailed maps of billions of stars, revealing the Milky Way's structure with increasing clarity, star by star, layer by layer. Despite this growing knowledge, much of the galaxy remains unseen, quiet, and unexplored, waiting patiently beyond the reach of light. As you imagine generations of people lying beneath the same sky, watching the same gentle glow, you may feel how constant the galaxy is, and how small each moment can be. The Milky Way has always been there, turning slowly, while nights pass into sleep. Every star in the Milky Way follows a path shaped by gravity. Some paths are nearly circular, others slightly tilted, but all move with quiet consistency through the galaxy. Over long periods of time, stars slowly change position. The Milky Way you see today is not exactly the same one that existed millions of years ago, though the changes happen so gradually they feel invisible. The sun itself gently moves up and down through the galaxy's disk, bobbing slowly like a buoy on a calm sea. One full rise and fall takes tens of millions of years. Occasionally, stars pass near one another, but the distances are so vast that close encounters are rare. Space within the galaxy is mostly empty, allowing stars to drift freely without disturbance. Some stars travel alone, while others orbit in pairs or groups. Many stars in the Milky Way are part of binary systems, quietly circling a shared center of gravity. Planetary systems are common throughout the galaxy. Thousands of exoplanets have already been discovered, and many more likely exist, orbiting stars in calm, distant systems. Some regions of the Milky Way may contain conditions suitable for life, while others are harsher and more extreme. The galaxy holds countless environments, each unfolding quietly in its own way. Yet even with all these possibilities, the Milky Way remains peaceful on human timescales, its changes measured in millions and billions of years rather than moments. As these thoughts drift through you, imagine stars gliding silently. Never colliding. Never rushing. The galaxy moves. And you rest, held safely within its slow rhythm. Far in the future, the Milky Way will continue its slow evolution, long after individual stars have completed their journeys. Change here is never sudden, it unfolds over immense stretches of time. Many of the galaxy's stars will gradually exhaust their fuel and cool into faint remnants. Red dwarfs, the most common stars in the Milky Way, will glow quietly for trillions of years before slowly fading. Star formation will continue, but at a calmer pace, as gas becomes less abundant. The galaxy will grow quieter, dimmer, and more settled as time moves on. The Milky Way's encounter with Andromeda will reshape both galaxies into a single, larger system. Their spiral arms will stretch and blend, forming a new, gently glowing structure. Despite this cosmic merger, individual stars will pass one another at safe distances, preserving the calm, ordered motion that defines galactic life. Over time, the combined galaxy will settle into a smooth, rounded shape, its brightest days behind it, drifting peacefully through space. The central black holes of both galaxies will eventually merge, releasing waves of energy that ripple silently through space-time, then fade. Afterward, the galaxy will remain larger, quieter, and still, holding the memory of everything that came before. As you imagine this distant calm, stars dimming, motion slowing, time stretching outward, you may feel how small tonight is, and how safe it can be to let go. The Milky Way will continue, whether you watch or rest, turning gently through endless night. Now, the Milky Way feels very far away, and very close at the same time. Even after trillions of years, some stars will continue to glow faintly, scattered gently through the galaxy like embers that refuse to rush into darkness. Long after bright spirals fade, the Milky Way's stars will move more slowly, their orbits widening as gravity loosens its grip over immense time. Eventually, most light in the galaxy will come from small, dim stars and stellar remnants, white dwarfs, neutron stars, and black holes, quietly drifting through space. The galaxy itself will grow darker, but not empty. Motion will continue, subtle and patient, guided by gravity's soft pull. Even then, the Milky Way will still be part of the universe's larger story, moving gently among other distant galaxies, all drifting together through expanding space. And beyond all of this, science does not yet know what the universe's final state will be, only that it will unfold very slowly, without urgency. Now, there is nothing more to imagine. The galaxy can continue on its own. You do not need to follow it. Your breathing is enough. Slow. Easy. Natural. Thoughts can drift. Like stars fading into distance. One by one. The Milky Way turns. Quietly. Without sound. And you can rest. Without effort. Without thought. Nothing more is needed. Good night, crescent moon. Let us begin not at the beginning, for that story is lost to time, but from within. From a quiet corner of a spiral arm, on a planet orbiting a rather ordinary star. From here, in the gentle dark, we can look up and see the first truth of our home, a faint, milky band of light arching across the sky. Ancient storytellers saw spilled milk, or a river of stars. But we now know we are inside it, looking out through the plane of a vast, spinning disk. This is our first fact, the foundation of our story. We live inside the Milky Way galaxy, a barred spiral galaxy roughly 13.6 billion years old. We are not observers from the outside, we are part of its fabric. And what a fabric it is! If we could step outside, we would see a majestic pinwheel of starlight, with arms gracefully swirling from a bright central bar. Our sun, and we with it, do not sit at the center, but in the suburbs. We orbit about 26,000 light-years from the galactic center, in a region of the Orion Spur, a minor arm nestled between the larger Perseus and Sagittarius arms. We are cosmic commuters, completing one journey around the galaxy's heart every 230 million years, a journey so slow, the last time we were in this position, dinosaurs were just beginning their rule. What keeps us, and the hundreds of billions of other stars, in this graceful dance? It is not empty space that holds the galaxy together, but an immense, invisible presence. The Milky Way is embedded within a vast, spherical halo of dark matter, a mysterious substance that does not emit light but exerts a powerful gravitational pull. This dark matter is the hidden skeleton of our galaxy, accounting for over 85% of its total mass. It is the unseen hand that guides the Great Spiral. And within this luminous disk, our solar system moves, but not in perfect silence. For we are sailing through a sea of tenuous gas and dust, the interstellar medium. Our sun and its planets are currently moving through a region of slightly hotter, more diffuse gas known as the local interstellar cloud. We have been within this cloud for tens of thousands of years, and will remain so for thousands more, our heliosphere gently parting this cosmic fog as we travel. So, as we settle in, picture this: we are residents of an ancient, spinning city of stars, held together by the unseen, sailing on a quiet voyage through a sparse, galactic cloud. This is our local address in the universe. A place of profound beauty and even deeper mystery. As we journey inward from our quiet suburb, the galaxy changes. The sparse starlight thickens into a glowing fog, a testament to the countless suns gathered here. We are approaching the metropolitan heart of the Milky Way, the central bulge. This region is shaped not like a flat disk, but like a giant, glowing peanut, or a cosmic football. It is a dense swarm of primarily older, redder stars, a stellar city billions of years in the making. But within this brilliant bulge, at the very axis around which our entire galaxy turns, lies its true secret. Not a brilliant beacon, but a profound darkness. For here, at Sagittarius A*, resides a gravitational anchor of almost unimaginable density, a supermassive black hole with a mass equivalent to 4.3 million of our suns. It does not devour all, it rules through gravity's silent pull, a sleeping giant around which the galaxy gracefully spins. This central realm is not a place of quiet. It is a cosmic forge. Here, vast clouds of gas and dust are compressed by turbulent magnetic fields and the sheer press of stars, giving violent birth to new stellar nurseries. In fact, the galactic center is the most active star-forming region in the entire Milky Way, a continuous, slow-motion firework display of creation. The energy here is so intense, it creates phenomena unseen in our tranquil spiral arms. Like the mysterious galactic center lobe. These are twin bubbles of extremely hot gas, stretching for tens of thousands of light-years above and below the core. They are a fossil record of a tremendous eruption from the black hole or a burst of star formation in the distant past, a pair of gentle sighs in the galaxy's long life. And yet, for all its power, seeing this heart directly is impossible for our eyes. A great veil lies between us and it, the zone of avoidance. This is not emptiness, but a thick lane of interstellar dust, fine, dark grains of carbon and silicon, that stretches along the galactic plane, obscuring our view of the brilliant core in visible light. We must listen with radio telescopes and peer with X-ray eyes to glimpse the truth behind the veil. So we know it is there, this dynamic, ancient heart. A supermassive presence, a factory of stars, shrouded in dust, the quiet powerhouse of our Milky Way. Having visited the heart, let us rise above the plane of the galaxy, to see its true shape. From this vantage, our home is revealed as a barred spiral galaxy. Its core is not a perfect sphere, but is stretched into a central bar, a dense highway of stars, from the tips of which the great spiral arms unwind like cosmic pinwheels in slow, stately rotation. We do not live in a major arm. Our sun sails through a smaller stream of stars in nebulae called the Orion Cygnus arm, or simply the Orion Spur. It is a minor bridge between two of the galaxy's majestic primary arms, the inner Perseus arm and the outer Carina Sagittarius arm. We are in a quiet, stellar neighborhood, nestled within a local spur. The spiral arms themselves are not rigid structures, but density waves, like traffic jams moving through a highway of stars and gas. As this wave of compressed gravity passes through, it triggers the collapse of giant molecular clouds, lighting up with the birth of brilliant, short-lived stars. The arms are the galaxy's glittering sites of creation, and we are currently passing through one of these gentle waves of star formation. This vast disk, where we and most stars reside, is remarkably thin. Proportionally, if the Milky Way's disk were the size of a standard vinyl record, its thickness would be less than that of the vinyl itself. Yet within this slender plane lies most of the galaxy's light, gas, and dust, the ingredients for everything we see. And our galaxy is not alone in its neighborhood. It is the second largest member of a small galactic cluster we call the local group, a gathering of over 50 galaxies bound by gravity. Our largest companion is the Andromeda Galaxy, a spiral even more massive than our own, drifting silently through the void some 2.5 million light-years away, on a course to meet us in a distant future. So, we are part of a barred spiral, living on a spur, moving through a wave, in a disk of breathtaking thinness, within a small family of galaxies. A place of precise, beautiful architecture. Beyond the brilliant spiral, beyond the last thin trails of stardust, the galaxy extends into a realm of ghosts and echoes. This is the galactic halo, a vast, spherical cloud of ancient stars, lonely globular clusters, and that unseen architect, dark matter. It envelopes our entire galactic disk like a faint, cosmic aura, stretching hundreds of thousands of light-years into the emptiness. Here, in the deep quiet, orbit the galaxy's oldest citizens, globular clusters. These are dense, spherical swarms of up to 1,000,000 stars each, bound tightly by gravity. They are fossils from the Milky Way's violent infancy, over 12 billion years old. Their stars are ancient and metal-poor, meaning they formed from the primordial hydrogen and helium that existed before generations of supernovae enriched the cosmos with heavier elements. The halo is also a galactic archive, holding the remnants of the Milky Way's ancient past. It is littered with stellar streams, long, ribbon-like associations of stars that are the dissolving remains of dwarf galaxies and star clusters that our galaxy has consumed over billions of years. We are surrounded by the gentle, gravitational ghosts of our galaxy's long-digested companions. And it is here, in this sparse outer darkness, that the Milky Way's true scale becomes humbling. While the bright disk is about 100,000 light-years across, the halo, defined by its sparse stars and the grip of dark matter, may extend up to 1,000,000 light-years from the core. Our galaxy's influence is 10 times wider than its visible light suggests. Within this immense volume, stars are not born. The halo is a stellar retirement home, a place of quiet drift. Its stars move in long, looping, randomly inclined orbits, unlike the orderly circular paths of stars in the disk. They are the galaxy's nomads, tracing slow, patient arcs that have lasted since the universe was young. So, as you rest, picture this: our brilliant spiral is a jewel suspended at the center of a colossal, dark sphere, a sphere filled with the oldest starlight, the ghosts of past mergers, and the silent, dominant presence of the unseen. Let us leave the halo's ancient silence and return to the vibrant disk, to a place where the galaxy breathes in, and creates. We find ourselves within a molecular cloud, a cosmic womb of cold gas and dust so vast it could contain 10,000 solar systems. Here, in these frigid, dark nurseries, gravity begins its patient work, pulling pockets of gas together until they collapse under their own weight. From this collapse, a protostar is born. A furious, spinning core of heat and pressure, hidden within a cocoon of gas. For hundreds of thousands of years, it gathers mass, growing until the furnace in its heart ignites. Nuclear fusion begins, the same process that lights our sun, transforming hydrogen into helium and releasing the light that will shine for millions, or billions, of years. A new star flickers to life in the Milky Way. Not all stars are born alone. Many are born in litters. Our galaxy is filled with open star clusters, like the beautiful Pleiades. These are families of a few hundred to a few thousand young, hot, blue stars, all formed from the same cloud at roughly the same time. They are siblings, bound loosely by gravity, destined to slowly drift apart over hundreds of millions of years as they orbit the galaxy. The material left over from a star's birth doesn't just vanish. It often forms a swirling, flattened disk around the newborn star, a protoplanetary disk. Within this disk of gas and dust, microscopic particles collide and stick together, growing over millions of years into planets, asteroids, and comets. Every planet, including our own Earth, was born in such a disk around a young star, a byproduct of stellar creation. And these brilliant nurseries are not permanent. The very stars they create will eventually destroy them. The most massive stars, burning fiercely blue and hot, live short lives of only a few million years. With their deaths in violent supernovae, they blast the remaining gas and dust of their birth cloud far into space, enriching the galaxy with heavy elements and ending the era of star formation in that region, while seeding the cosmos for the next. So, within these glowing clouds, the cycle is written: from cold dust, a star is born, around that star, worlds may form, and from that star's death, the ingredients for future stars and planets are scattered. A slow, beautiful exhale of light and matter.